Hi there, we need to solve these simultaneous equations. We'll call this equation 1 and this equation 2. We'll try and rearrange equation 2 because there's nothing we can actually do here with x times y is equal to 270. If we divide both sides by y, we won't make any progress, nor if we divide both sides by x. So if we look at equation 2, we can rewrite it as the log of x divided by y squared. So this would have been log y squared, and that power now becomes a factor. The negative sign between this log and this log allows us to write it as a division. That's rule 2 of logarithms. If you look at my previous videos, I explain and give an example of the use of rule 2. Now this implies that x, I forgot one thing, is equal to 1. So this implies that x over y squared must be equal to 10. Because if we take the log of 10, it's equal to 1. Or we can write this as x is equal to 10y squared. And now we can make a substitution into equation 1 because now we know x, or we could have used y, just that x is easier to use. So if we substitute x equal to 10y squared in 1, what do we get? We got 10y squared times y is equal to 270, which means that 10y cubed equal to 270, so y cubed implies that y cubed is equal to 27. Which means that y is equal to 3. And if y is equal to 3, we can find x, because x times 3 is equal to 270, which means that x must be equal to 90. So our solutions are y is equal to 3 and x is equal to 90. Thanks for watching. I'm Alistair. Bye for now. In this video we'll talk about rule 3 of logarithms. And this states, and this is a very important rule, log to the base 10 a raised to the power of n is equal to n log 10a. So that power becomes a multiplier of the log. And we also have ln a raised to the power n is equal to n ln a. Let's look at example 2. We have 27 ln 3 minus ln 3. How do we simplify this? Well, if we use this rule here, so we have it in this form, which is the right hand side, and we want to move back to a simplified form. Now the base is 3, so we have ln to the base 3. It's raised to the power of 3 to give you 27. So that's 3 3s, 9 9 3s, and 27. So that's n. And ln3 follows. Now we apply rule 2 here, so we have ln 27, because 3 raised to the power of 3 is 27, and that's divided by 3. Now ln applies to both this part and that part, and it's now a division, which gives us ln 9. So from this we simplify it to ln 9. What about this? 4 ln 3, well, this is equal to ln, this is the base 3, and we're raising it to the power of 4, which we can simplify to ln 81. What about 3 log to the base 10 of 5? Well, we have log to the base 10, we have 5 here, our base, and we're raising it to the 3rd power. So n is 3, which simplifies to log to the base 10 of 125. Being able to manipulate logarithms is very important and useful. Where would I use logarithms? Well, we could use it for solving exponential equations, especially using rule 3 that I just covered. So exponential equations. We can explore exponential functions. We can explore them. We can use it in calculus. There are lots of uses in calculus, for instance, the slope of functions. Or the area bounded by certain curves. pH level of chemicals, detection of half-life of a radioactive, so half-life detection of a radioactive element. Oops, spelled that wrong. Thanks for watching this video. I'm Alistair. Keep practicing. Bye for now. We'll tackle rule 2 in this video of logarithms. And it states that if we have the log to the base 10 of a divided by b, we can simplify this to log of base 10a minus log base 10b. And for the natural logarithm ln, which is the logarithm to the base e, we have similar pattern. Ln of a over b is equal to ln a minus ln b. Let's look at an example. We have ln 45 minus ln 14. We can write it ln brackets 45 divided by 14. So in words, we have the quotient or the division of one logarithm by another, or one value by another. The logarithm of one value divided by another is the same as the logarithm of the numerator added to the negative value of the denominator, or the denominator subtracted from the numerator, to base 10. Same applies for the natural logarithm, that's the base e. What's a real life application of logarithms? Well, pH level of chemicals. pH level of chemicals can be calculated using logarithms. Noise levels, and we can detect the half-life. So detect half-life of a radioactive element. So these are all real life. Let's write this here. Real life applications of logarithms. It's worthwhile learning the three main rules, and most importantly, to practice. Thanks for watching. This is Alistair. Bye for now. Hello there. Today I'd like to cover 3 rules. So each video will have one rule. I'll start with rule 1 for logarithms. So rule 1, what does it state? It says that if we have log to the base 10 of a times b, you can write this as log to the base 10 of a added to log to the base 10 of b. This also works for ln, which is to the base e, natural logarithm. So if it's a times b, ln a add ln b. It's important to be able to work from the right hand side to achieve the left hand side, and vice versa. So let's look at an example. If we want to simplify log to the base 10, 7, log to the base 10, 5. We can write log to the base 10, 7, log to the base 10, 5 as log to the base 10 of 7 times 5, log to the base 10 of 35. So that simplifies it. If you wanted to evaluate that using a calculator, it'd be a lot easier than trying to evaluate this expression. Why learn logarithms? Well, it's actually valuable in calculus. We can calculate the slope of functions or curves. We can calculate the area bounded by some curves. Noise levels, logarithms are used in noise levels. Detection of half-life of a radioactive element, and many other uses. Thanks for watching. Bye for now. How do we evaluate this? Well, first, the index is itself a logarithm. So we'll simplify that first, and then we'll know what we're actually raising 5 to. So log 5, log to the base 5 of 25. So this is asking the question, what should we raise the base 5 to get 25? Must be 2, so because 5 squared is equal to 25. So that evaluates what our index is. So this is the same as writing 5 squared, which is equal to 25. What should we raise the base A? What power should we raise it to get a cube? Well, the base A is raised to the third power, so we must raise this base to 3 in order to get a cube. With a base of 9, what power or index should we raise it to get the square root of 9, or 9 to the half power? It must be a half, because we raise 9 to the half, we get 9 to the half. And finally, with a base of 2, what do we raise it to get 2 cube? Must be 3. Alternatively, you could look at this as log to the base 2 of 8. What is that equal to? What do we raise 2 to? Which power, what index to get 8? The answer is 3. Either way is correct. Thanks for watching this video. My name is Alistair. Any questions or comments are welcome. Don't forget to like. Don't forget to follow or subscribe for more videos like this. Bye for now. Hi, how do you evaluate this logarithm without the use of a calculator? Well, it's simply as asking, what power should we raise 0 to get 1? That's what this is asking. And we simply know 3 raised to the power of 0 is equal to 1. So this evaluates to 0. Here's another log to evaluate, or logarithm to evaluate. It's asking the question, what do we have to raise 5, the base 5, what do we raise the base 5 to get 1 over 25? We know that if we raise the base 5 to 2, or square it, we get 25. We want the inverse of that, which is 5 raised to the negative 2, and this is equal to 1 over 25. So we know log to the base 5 of 1 over 25 is equal to negative 2. How do we evaluate this one without using a calculator? Well, we can rewrite this as log to the base 10, and we have 10 cubed, and we're taking the square root of that, which is log base 10 to the 3 over 2. So it's asking, with the base of 10, how do we, or what do we raise the base of 10 to get 10 to the 3 over 2? Our only answer is 3 over 2. We must raise the base 10 to the power 3 over 2 to get 10 to the 3 over 2. So log base 10 of root 1000 is equal to 3 over 2.